Right. So last time we mentioned that we can do operation of more than one function, right? We can do add, subtract, multiply, divide. So here is kind of like going backwards in question 5. Okay. So we want to write the function h of x as sum, difference, product, and, and quotient of two functions. So going back, try to break it apart into two functions that can make up the result. Okay, so it's like you are the teacher, you're trying to make up examples. So I can go over the first one. Okay, so make sure you need to show two parts. One part is you need to tell me what's the f of x, right, and g of x, and then whether you are trying to do f plus g or g plus f. Well, for adding, it doesn't matter, right? Adding, the order can be anyways, right? Okay, so show the two things. So for example, right, I want to break up h of x, right? H of x is the result of adding. So Donna, what do you want the first function to be? Donna?
What?
Yeah. What do you want the f of x to be? Like, can you? Hmm?
I don't know.
You don't know? Okay. How about Cindy?
I don't know.
Huh? It can be anything. Everybody will have different idea. We want to create two functions. It's up to you, right? Make up two functions so then they will add up to h. So there are many ways, many different answers depend on you. William, do you want to try?
Yes, the
Okay.
master has come.
You are the dying master, right?
Yes, very dying. Okay. Wait, plus together?
Yeah, add together.
So like, can it be like 2x plus 1x and then 3x plus x?
Oh, hold on, slow down. Are you talking about f of x right now?
Sure. Wait, f and g. I just said both. But like, I don't know.
One at a time. What do you want the f of x to be?
Okay, 2x
Mm-hmm.
plus 1
Just
and
two.
then
Okay, and what do you want the g of x be?
3x plus x. Wait, no, one x and the other. Wait, two x's. The f of x plus x instead of plus 1.
Oh, 2x plus x?
Yeah.
Then that's like 3x then, right?
I don't know what I'm doing.
I'm confused.
I don't know what I'm doing.
Okay, anyone else wants to try? Eric, what about you?
You do 4x squared plus
4x
x
squared
plus x,
plus x, and the other one?
2x squared plus x.
2x squared plus x. Okay, so let's see if it works. So let's say if I add them up, right? 4x squared plus 2x squared, does that equal to 6x squared? Donna?
Yeah.
Yeah, okay. What about x plus x? Do they add up to 2x?
Yeah.
Yeah, so this will be an example, right? So everybody can create a different one, different pair of function. So let's try another one, okay? Just to make sure everyone gets it, right? So that was an example. So Catherine, can you also give me two functions? Catherine,
I don't know.
make up some number.
5x
5.
squared
Uh-huh. Anything else?
plus x.
Plus x. Okay. And then what about g of x? We need them to add up to 6x squared plus 2x. Need them to add up to h.
X squared plus X.
Yeah, very good, right? It's not too hard. You just need to make up one and then try to get the other one, right? Okay, so everybody can write down your own, okay? And I'll get one more. I know that. Okay, Tiana, how about you? What's your
3x squared
Mhm.
plus x.
Okay, what if I try plus 5x? I'm just making things up. What do you think the g of x has to be?
3x squared
Mhm.
minus 3x.
Yeah, okay. So you think about if they add up to 2x, right? 5x need to add a negative 3x to make 2x, right? So you can be very creative, very flexible, okay? And you can double check by adding them up.
We can use anything.
Yeah, because it asks you to write out your own function, right? As long as it matches. So the first question is asking you to do sum, right? Adding. Now the second one is using difference. What does difference mean, Eric?
Subtraction.
Yeah, so we need to use subtraction this time, right? Subtract the two functions and then to get the result, right? You can do f subtract g, okay, of x. So make sure you also write this out, right? Otherwise, I would think maybe it's f minus g or g minus f, we're not sure. Okay, so when you finish the difference, please raise your hand. Okay, once you got the difference, raise your hand. Okay, Donna, do you have any questions?
No.
Okay, let's see. Okay, how about Cindy? You try this time. What's your example?
Wait, I was supposed to think of a different one.
Yeah, make up. But then your result is the same. It's still trying to get h.
Oh, I use like the fx and gx for the sum and solve the difference for that.
But then that difference, would it be the same?
I don't know.
Well, what's your f? Let's check.
Wait, what?
What's your f of x? You say you have, what did you use?
I used the one for the sum.
So what is it?
3x squared plus 5x.
Okay, and what's your g?
3x squared minus 3x.
Okay, and we want to, if it works, that means if they subtract, right? Because we're doing difference. So they have to subtract to equal to h. Okay, so if you subtract them, what do you get?
8x.
Yeah, the 3x squared is gone, right? What are we supposed to get?
8x.
We want to get the h. Do you understand the question?
Oh, okay, wait, that's my bad.
Yeah, we are trying to go backwards, right? In the homework, they give you two functions, and then you do adding, you do subtracting, right? You simplify. Now we are going back, try to break it apart into two functions, okay? Understand what we're doing now?
Yeah.
Okay, so the answer won't be the same as the sum. So you try again, okay?
Can I?
Yeah, Donna, what's your answer?
7x squared minus x. X squared plus x.
Hold on, slowly. You said 7x squared minus what?
X.
X, okay, the other one?
X squared plus x.
Plus x, okay, so let's see if it works. Now we want to subtract, right? You are doing f minus g, right?
Yeah.
Okay, so 7x squared minus 1x squared will be 6x squared. That works. The next one, negative x minus x. What's that?
Oh, shoot.
Okay, so the second part doesn't work. How do we fix it then? How do you want to modify?
Switch the negative sign to the bottom
So switch.
Yeah.
to have plus x for f and then minus x for g.
Okay, oh, oops, minus x for g. So x minus negative x will become add an x, then that will work. Yeah, okay, that will be an example. Okay,
I hope.
Yay.
okay. All right, Cindy, have you found one? What's your f and g? Cindy?
8x squared plus x.
Okay, and the other one?
2x squared minus x.
Minus x, okay. So if we subtract 8 minus 2 will be 6, right? 1 minus negative 1 will be 2. Yeah, it also work. So there are many ways, okay? So everybody could be different. So you can check it by yourself. So if I'm marking your homework, right, there's no answer key to that, right? So I have to check each one of your choice, see if it matches, okay? So Cindy's answer is correct, Donna's answer is also right, okay? Next one is the product. Product means multiply, right? So we need to turn this into two functions multiplying together. So I will let you try as well. Think about which two function multiply can make 6x squared plus 2x. Okay, if you get it, please raise your hand. Okay, if you've written it down. F times G. Okay, so Samantha, could I check your answer? What do you have?
2x plus 2x for f of x.
2x is for f of x, okay. Like that?
2x plus 2x.
For, you mean 2x plus 2x, like this?
Wait, that doesn't make sense.
Is that for f? Samantha?
Mhm.
Okay. And then 2x plus 2x, isn't that just 4x? Hmm? I can't hear you, Samantha. Is that what you mean, 2x plus 2x for the f?
Mhm.
Yes or no?
Yes.
Yes, okay, then we can just simplify into 4x, right? Is that what you mean?
No.
Okay, then what do you have?
2x plus 2x and
2x plus 2x. Okay, let's see. 2x. And what's your g?
3x plus x.
3x plus x. Like that? Is it? Hello?
Yes.
Yeah, okay, so now we want to check, see if it works, right? If it's 2x plus 2x, that means it's like 4x. And I want to multiply with the other one, right? You put the dot means multiply. 3x plus x. What's 3x plus x, Samantha?
4x.
Yeah. So if we do f times g, that means it's 4x times 4x. What would that equal?
16x squared.
Yeah, so it will end up with a 16x squared instead of 6x squared plus 2x, right? So that's not what we want, right? So that's, yeah, so you can think about it again. We need multiplication to work. Let's see. Donna, do you have anything?
Yeah. 2x for fx.
2x for f of x. How about g?
3x plus 1.
3x plus what?
1.
1. Okay, let's try. Multiplying, right? So I have 2x multiply with 3 plus 1. How do we multiply this? Donna, how do we check?
6x squared.
So we need to distribute, right?
Yeah.
Yeah. 6x squared will be the first one. And then multiply with the 1 will give you
Plus 2x.
plus 2x. And it matches the original question. Okay? So that
So
will,
it works.
yeah, it works. Okay? You can see if it works by multiplying out. Okay? Trudy, what about you? What kind of answer do you have?
I just had 7x. Wait, no, wrong one. 2x for fx, and for g of x I have 3x plus 1.
Okay, so basically the same, right?
Yeah.
Yeah, okay. Anyone has a different one, then you want to check if it's right.
Yes.
Okay, William, what do you have?
For f of x, I have 6x squared times plus 2x.
Mm-hmm.
And then for g, I have 1.
All right.
Does
Good
that
job.
work?
Does that work?
Does that work?
Technically, it works, right? Because anything times 1, it works. That's a good,
Good.
yeah. But then if it
So,
won't work, okay, I would like you to try think more other than 1. Otherwise, everything you can
Damn it.
do 1, right? Like adding, for example, adding, you could say plus 0, right?
Oh, yes.
And then
We beat the
difference,
system.
right? Difference, then you do subtract 0, right? Then everything will be the same answer, okay? You gotta create something that's other than 1, okay?
Okay.
Yeah, it is like homework, okay? All right, let's move on to quotient. Quotient means dividing. Is there anyone else want to check if your answer is right, like for product? Okay, and we'll look at quotient. So do not use 1, okay, for quotient. So quotient will do F over G, okay? F divided by G of X. So if you get an answer, please raise your hand. Remember to raise your hand if you're done. Anyone has trouble? Okay, let's look at one example first, okay? So Vicky, what do you have?
36x squared plus 12x,
That's 12x, okay?
and
And
then 6.
just 6, okay?
Yeah.
So if we divide 36 divided by 6, yeah, give you 6x squared. 12 divided by 6 will be 2. 2x, right? 12x. Yeah, that works. Very good. At least you're not using 1, right? Divide by 1. Okay. What about William? Are you using 1 this time?
I did not.
What do you use?
I have 12x to the power of 3 plus 4 to the power of 2, and 4x to the power of 2,
Okay. And
and
then
then divided by 2x.
2x. Yeah. So you could have also variable, right? If you want to divide by a variable, then you need to make the numerator have a higher exponent. Okay, Catherine, what about you? What's your input? What do you have? What do you have?
6x cubed
Mm-hmm.
plus 2x squared
Mm-hmm.
divided by x.
Divided by x. Okay, sure. That also works. Very good. Okay. Any question here, Eric, Tiana? Because I didn't see you raise your hand. Did you get an answer or?
Yeah.
Yeah.
Yes.
Yeah. Okay. All right. So this question B will be similar. Okay. So we won't spend time on this one. Okay. So in your homework, you will have similar question like this. So just be creative, right? You can create your own and make sure you double check by doing multiply, divide, right? And then see if it matches. Okay. So today our focus is on the next page, the composition of functions. All right. So anybody heard of composite function, this word? If you heard of it, please raise your hand. No? Okay, no one has heard of it. Oh, William? Yeah?
Nope.
No?
Yes, not really. No.
Not really. Okay. So let's review a little bit what function does, right? So if we look at the previous page, for example, if you see like this one, question 4a, f of -2, right? That means you take -2 and then plug it into the f of x, right? Plug into the x and then calculate. So you have an input, right? And then you get an output. The output is -3. You get -3. This is the output. Okay, so input output, so it's like you throw the material ingredients into a machine and then the machine will produce a product. Okay, so now for composite function, you think of it as two-step machine, right? So if you want to build something, first you need to have the raw material and then you put it into one machine, right? One factory, and comes out the little components. And then those components is going to another factory and then to maybe build up the car, right? So it's not just one step, it's two functions. Function, you can think of it as factories, right? Factory. Okay, you have more than one factories. So for example here, okay, G of X maps means taking, okay? You take the numbers from A, make it into B. So it's like the ingredients, the little like the nails, the steel, the cardboard, right? All the ingredients, and then turn them into little components. Okay, B. Makes A into B. And then the other factory will take the material you get from B and then turn them into a product. Okay, maybe make it into, put them all together into a car, right? So that's two functions, right? Each function does different things. And composite function means it does one thing at one time, okay? It takes whatever in the beginning, right? Combining both functions and then just directly produce into a car. So maybe you can think of it like a bigger factory. Inside you have two factories. So H is the bigger one, right? H combines, right? Composite. Composite is where you can think of it as combine. Okay, that's the idea. Any questions so far? Okay, so we'll use an example. Okay, so here we have a symbol here. H of X, and then you have F, O, G, right? The little empty circle. So this is not fog, okay? This one is, and this part is not multiplying. So what this actually means is F of G of X. So there are two steps, two layers. Okay, we'll say this together. So everyone turn on your microphone. Okay. Yeah, everyone turn it on. Okay. Tony, Trudy. Yep. Okay. So we'll say this together. H of x,
H of
H
X.
of X,
H of X.
f of g of x.
F of
F
G of
of G
X,
of
G of
X.
X.
Okay. So for example, this number, we'll say this together as well. F of g of 8.
F
F
of G of
of
8,
G of 8.
Okay. So which one is the input? Which
F of G of 8.
the most inner one will be the 8. Okay. So 8 is like your raw material. Okay. So first it will go into the G factory. Okay. So the way you can picture it is I will start with a G, right? And I have 8. 8 is your ingredient. So I will put 8 into G of X. G of X is up here, right? This factory. So I put 8 into the G of X. So I will have G of 8, which will equal to what? Tiana, what's G of 8?
16.
Yeah, 16, right? You put into the X, 2 times 8 is 16. So 16 is like the little component, right? You made it from other ingredients, turn into a component. And then that component is going to the second factory, okay? So I will continue the work, okay? So it will look like this. F of G of 8, because we found G of 8 to be 16, so I write 16 now. So G is gone, right? Now the 16 will continue to move into factory F. So this one, okay? So it'll be F of X. So 16 will go in, and what will come out, Vicky?
4.
Yeah, so it will come out 4, right? So it'll be F of 16 and will come out of 4. Okay, so your final answer for this will equal to 4. So kind of like a relay race, right? So you pass the stick to the next one complete the race, right? And then finish to the finish line, okay? So I would like you to try the right-hand side as well, okay? Question B on the side. So this one is F of 16. And then fill in the numbers in the circles as well. Okay, show the steps and the circles. So once you finish both, right, the circles and the steps, please raise your hand. Anyone is lost here? So you go from inside out, okay? The one that goes in first is the one on the inside. And then you get the inside number and then sub it in and then get the next number. Okay, Samantha, can you tell us what's your steps?
16.
Yeah, 16 will go into the F first. So what do you get?
Then 4.
4, yeah. So it'll first become F of 4. And then
Then 2.
and then becomes 2. Okay, very good. And Catherine, what goes into the first circle?
Is 16.
Yeah, okay. And then this one will go into which function? F or G?
G.
But the question has no G inside.
Oh, F.
Yeah, so we'll have f of x, and then what comes out? What comes out?
F 16.
Yeah, f of 16, what's that equal? Catherine?
8.
8, why is it 8?
I don't know.
You know how to find f of 16?
4.
Why is it 4? How'd you get 4?
Because it says f of x is square root of x.
And then?
So you square root 16.
Okay, very good. All right. And then the 4 will continue to go into the f again. And what will come out at the end?
2.
Yes, okay, very good. All right. So the bottom, we have 3 questions here, okay? We'll talk about these one. These one we haven't done yet, right? These red box, we'll do that later, okay? We'll work with numbers first, okay? It will be easier. So in question 6, we have 3 functions, f of x, g of x, h of x, and actually 4 of them, and k, right? F, G, H, K. So each one of them it deal with different ones, okay? Make sure you go from inside out. You will get different answer if you go the wrong order, okay? So I would like you to try A, B, C. If you finish all 3 questions, then please raise your hand.
We don't write the circle, right?
Yeah, you don't need to draw the circles now. You just follow the steps like we did up here, okay?
Okay.
Circle is just to help you see the steps in a different way, okay? But in homework, you don't need to draw circles. Has anyone here learned this before, the composite function? No? Okay. Remember to raise your hand if you finish all 3. Anyone here has no idea at all what to do? Okay, I can help you to at least get started.
Jason, H doesn't have a X. How do you use it?
So that means it does not matter what you put it in. What's the output?
Oh, okay.
Yeah, okay. It doesn't matter what you go in, what it goes in, it will stays at 3. Any trouble there? Tiana, Samantha, Catherine? Doing okay? Remember to raise your hand if you finished. Okay, let's check question A first. Okay. So, Vicky, what's your answer for A?
8.
8. Okay. Eric, how about you? Eric, what's your answer for A?
15.
15.
Yeah.
Okay. William, what about you?
For A?
Yeah,
15.
15. Okay. Tiana,
Yes.
what's your answer for A?
15.
Also 15? Okay,
Mhm.
so let's see, okay? Uh, so we start with 5, right? 5 will go into the G first, right? So f of, so we can do on the side. G of 5, so 5 minus 3, that will give you a 2. So this is how you will show the work, right? First step, you figure out the inside, okay? And then 2 will go into the f. F is much longer, so you can do step by step. 2 squared plus 3 times 2 plus 1, okay? So that will be 2 squared will be 4, 4 times 2, 8, 8 plus 6 plus 1. So that gives you 15. Okay, so that should be 15. Catherine, which question are you working on, Catherine?
Second one?
Second one, how about C? Have you got C yet?
No.
Not yet, okay. Did you get question A correct?
Yeah.
Okay. So finish question B and tell me your answer, okay, Catherine? Yeah.
Is it negative 2 and 3/4?
2 and 3/4. So we have a fraction here for B. Yeah. Is that what you mean? 2 and 3/4?
Yeah.
Okay. Samantha, what about you? What do you have for B?
-2 and 3/4.
Negative 2 and 3/4. So same thing. Okay. Donna, what about you? Donna.
The same.
The same, okay, right? So let's quickly go over that. Okay, we start with k, right? K of -2, so I'll do on the side. -2 plus 1 is -1 over 2 times -2, so that will give you -4. So g of -1 over -4. Simplify that into 1/4. And then we need to put put 1/4 into the g. So that will be 1 over 4 minus 3. We can get common denominator. So that will be 12 over 4, negative 11 over 4, right? So that will become this. Okay, looks good. Okay, last one, question C. Cindy, what's your answer for C?
0.
0, okay. Trudy, what about you?
I got 2 over 3. 2
Two.
over 3.
2 over 3.
Yeah.
Okay. Okay, Tiana, what about you?
I got 1/2.
1/2. Okay, so this one is tricky, huh? We have all three different answers. William,
Okay, hi.
hi. What do you have? Do you have any?
2 over 3.
You have 2 over 3. Okay. Let's see. Vicky, what about you?
I got 1.
1. Okay, that's another answer. Okay. Eric.
I got 2 over 3.
Okay, sounds like 2 over 3 has more votes. Okay, so let's go over this one. Okay, this one might be harder, right? So which function do we sub in the 2 first? Donna. We should take the 2 and put it into which one first?
The GX.
Yeah, g of x, right? So I will write the outside k of h of, now g of 2. So 2 subtract 3, that's a -1. So it become -1. So that's your first layer, right? First layer on the inside, figured out. And then h of -1, now we need to do this part, the red part. We have to look at the h because it has no x. So what is h of -1? Cindy?
Just 3.
Yeah, it will stay 3. It doesn't matter what you put it in, right? H of 5, H of 11, H of -1. There's no x value for you to change. So it will come out as 3 again, right? So it'll stay there. And then finally, you just take 3 and then put it into k. K has a fraction, right? This one is the k one. You put 3 in. So 3 plus 1, that will make it a 4. 2 times 3. So that's 4 over 6. That will simplify into 2/3. Okay, anyone has questions about this? Okay, if not, okay, if you have questions, you stay after, okay? Otherwise, we'll take a break for 15 minutes. So I'll see you at 2:45, okay?
Oh,
Yep.
oh, never, nothing.
Yep.
School's gonna start.
What's gonna start?
School.
School is going to start. Are you going back?
I don't know.
They say you go back once a week, right?
Yeah.
Okay, and do you know like what you're gonna learn? Like which courses?
No.
Did they like call you or what? Send you an email?
Yeah, they sent me an email.
Can you show me like what does it say?
How do I show you?
You can share. Is it on your computer, right? You can share.
Oh, yeah.
Okay, I'll
Okay.
stop by sharing. Then you can share.
Hold on.
Okay. Okay, so before the break, we just went over a question that has number, right? Number input. So this time we're going to do something a bit different. We're gonna use X as the input. So instead of having a number inside, I will have X as the beginning, right? So remember that all the X is like a box. So you can write it on the top here, okay? So the f of X, you can think of it as having a box like that. So whatever that goes in here will go here, right? 2x. So if it's g of phi, it will be 2 times phi. So similar for f, it's the same thing, right? This one you already know, right? You just put it in, treat it like a box. Okay, so what that does here is, in this question down here, oh, Samantha, we're missing Samantha, okay. Okay, Samantha, right? So here we want to do f of g of x. So because the x is the input, if I put x into the g, right, put it into the red box up there, it will be just 2x. So when you show the work, the first step, it will become f of 2x, right? Because g of x here is the 2x. So you don't get a number, okay? You will get an expression at the end. And then the next part, okay, I'm gonna show it on the next line. So 2x will be your new input. So you will put it into the square root. So this part is the box, right? So f of 2x means the 2x is going to replace with the red box. So it will look like square root of 2x. So that will be your final answer. Any questions so far? Okay, so what this does is it will take whatever at the beginning, and then if you put it into your composite function, it will give you directly to the end. So go take the airplane straight to here. So this one is your h of x, the composite one, right? And the h of x comes from the top, right? Remember over here, h of x takes the original ingredient and then output to the final product, the C, right? Go straight to C instead of A to B and then B to C. You go straight to C. So for example, we try, right? Let's say we want to do H of 8. So if I put it into here, it will be square root of 2 times 8. And square root of 2 times 8 is square root of 16, which is 4. and that is also the same, right? Same as the 4 that we got. Okay, so the expression right now, what we are trying to do is to find a new function that can take the original number, go directly to the final, right? So that's the purpose of getting the composite function. Let's try another one. Okay, so this one here is f of x. So go through this together. Okay, we start from inside. So it will be f of what should go inside this bracket. Dingus.
Oh my god, you actually called me dingus. That is amazing.
Yep.
It should be square root x.
Yes, very good. Okay, you take the original function inside the f. And then this function, square root x, is going to inside the f again. So what do you think will be the final look, Tiana?
Square root and then square root x.
Yeah, very good. Okay, square root, and then inside you have a square root x. I'm gonna use red, okay, so you can see clearer. Okay, so you take the whole square root and put it inside the box. Okay, so this will be your final answer. And this function, we call it the h of x. Okay, your composite function. So this is the composite. Okay, where did it go? Here. Okay, composite function. Okay, so any questions so far? So here we're gonna try some question that has the x as our input, okay? We want to place the function inside another function. So that will be the next page, okay? So we'll do it more slowly, okay? So we'll start with question A. So everybody try question A first. We have F, G, and K. Here, I want to put which function into which function. Samantha, which function should go inside? Is it F inside the K or K inside the F?
A inside the F.
Yeah, very good. Okay, so place K into the F. So everybody try it. And then what we need to learn here is also remember to write down the restrictions. Okay, if there's any. And also, if there's anything we need to simplify, we need to simplify. Okay. So if you got an answer, please raise your hand. We'll go over this together. Don't forget to write the restriction, okay? If there's any restriction, think about denominator. Okay, let's get some expression first. Okay, stunks. Okay, what's your expression?
F and then brackets inside 2x plus 1x minus 1.
Yeah, do you have the final?
Oh, okay. The final one,
Yeah.
3
Mm-hmm.
and then times 2x plus 1 over x minus 1 plus 1.
Mm-hmm. That's
Plus
your
1 on the outside.
okay. Did you simplify it at all?
Nope.
No. Okay.
Do I have to? I'll do
Yeah.
it now.
Yeah. For your homework as well, we need to simplify it. So think about
Okay.
how to simplify it. Okay, Cindy, what about you? What's your final expression?
7x plus 2 over x minus 1.
Okay. Anyone else? Okay, Trudy, what do you have?
I also got 3 times 2x plus 1 over x minus 1 bracket plus 1.
Okay, so you got the same as William.
Yeah.
Okay. Yeah, so think about how to simplify it, okay? Because this won't be the final answer yet. We need to combine it, okay? Kiana, how are you doing?
I have the same answer as the second one, trying to simplify it.
Trying to simplify, okay.
I
Yeah.
got the simplified version.
Does it match the same?
No, not Cindy's.
Okay, what do you have?
5x minus 2.
Over x minus 1?
No, just
Or the whole
5x.
thing is just 5x minus 2?
Yeah, I divided the thing and
Okay,
then plus 1.
okay. So final answer is 5x minus 2 and this one. Okay. All right, let's check the step. Okay, let's don't move on to B yet. Okay, we need to make sure you know how to simplify first. So we start from K, right? K needs to go inside. So it will become F of K. K is 2x plus 1 over x minus 1. So you treat this as your input, right? See, I boxed the red. So that will be the box here, right? Whatever you see inside the bracket, it will replace the box, right? So everybody got this part right, except the simplifying, right? It'll be 3 times 2x plus 1 over x minus 1. Okay, so what you need to do now, just think about how to simplify fractions, right? When you multiply, right? Multiply fractions, the 3, you can write it as 3 over 1, right? The 1, you can also write it as 1 over 1. Oops. Okay, write it as 1 over 1. So let's multiply the two things first. Top times the top, then that will give you 6x plus 3, right? We do distribution over x minus 1 plus 1. Okay, how do we add the fractions together, Vicky?
Same denominator,
Yeah, common denominator. What is the common denominator?
x minus 1.
So I will put a long line and I'll write x minus 1 in the bottom. So 6x plus 3 plus the 1 needs to become something over x minus 1. So it has to be the same one, right? X minus 1 over x minus 1 is same as 1. Okay, William, got it so far?
Yes.
Yeah, okay, so that's how you would simplify. Now you just collect the like terms on the top. So add it together. So Trudy, what do you have on the top?
5, wait, no. 7x plus 2.
Yeah, 7x plus 2 over x minus 1. Okay, so Cindy was correct. Okay, so this is the answer. Are we good? So what else is missing? Are we forgetting anything here? Anyone? Eric?
Restrictions.
Our restrictions, yes, very good. Okay, so what's the restriction?
X cannot be 1.
Yeah, x cannot equal to 1. Okay, this is part of the answer as well. So make sure you have the simplified version and also the restrictions. Okay, now for question B, you see that this one is the symbol is looking different, right? So that's another way to write composite. So let's go back to A, right? The way to write this, a different way to write f of k of x is to write f and then a little circle, empty circle, and then k, right? The same order. And then put in bracket and write an x on the outside. Okay, they both mean the same thing, just different symbols. So for example, like question B, how do I rewrite it? Tiana, how do we rewrite this one?
G bracket F bracket X bracket bracket.
Yeah, very good. So it will be g of f of x and then bracket. Okay, so I'll let you finish this as well. So think about which one goes inside, which one goes outside, and then make sure you simplify it. And if you know how to write restriction, write this one out, okay? This restriction is a little bit different. So if you get an answer, please raise your hand. Okay, so Vicky, can you tell me the first step?
G bracket 3x plus 1.
Yeah, very good. If you finish, please raise your hand. And Catherine, what's the next step?
square root of 3x plus 1 minus 3.
Okay, very good. Okay, you could put a bracket if you want, right? For this one, it doesn't matter, but sometimes it's safer if you have a bracket. Okay, and then what do we do next, Samantha?
Simplify it.
Yeah, so which will become
3x minus 2.
okay, very good. Okay, did anyone get different answers here? So this one will be your final composite function, okay? So we call that h of x, or you can call that g of f of x. And we need to get restrictions now. Okay, what's the restriction here? Cindy?
I'm I'm not sure if it's right, but
What do you have?
I wrote it has to be greater than 2/3.
The x has to be greater than 2/3.
Yeah.
Yeah, okay. Anyone else got something different? Tiana, do you have the restrictions?
No.
No, not sure about it.
Yeah.
Okay. How about Stunks?
I got the same thing.
Same thing.
Yeah.
Okay. Donna?
I'm not sure.
Not sure. Eric?
I got the same thing.
Same thing. Okay, let's think about
Oh wait, I got greater than or equal to.
you have the equal.
Yeah, me too.
Huh? How come you don't say anything, Donna? Okay.
Because I'm not sure.
Oh, you're not sure, it's fine. You can still say it, right? Okay. So let's think about, should we have equal or not equal, right? So for restriction, it means the value you cannot use, right? Like fraction, then you think about, oh, x cannot be 1 because it makes the denominator equal to 0. For square root, what kind of rule do we need to have for the inside values? Cindy, what rule do we need to have for the inside values?
Has to be not negative.
Not negative, right? So could it be 0 then?
Yes.
Okay. Square root of 0, what does it equal?
0.
Still 0, right? 0 times 0 will be 0. So anything inside must be greater or equal to 0. So make sure you write this down. This is for any square root restrictions. Okay, you focus on the inside. So the thing inside here is 3x minus 2. So you grab this inside, and then you make it greater and equal to 0, and isolate the x from here. So we move the 2 over, right? And then divide both sides by 3. Then that will give you greater and equal to 2/3, okay? So that's why we need to have the equal sign. Are we good? Okay, so for square root and fractions, those are the two places you need to worry about restrictions. If you don't see those two, usually there's no restrictions. All right, so we have two more. So I'll let you complete both of them on your own. Okay, and when you finish, please raise your hand, then we'll go over those two. All right. So this time, remember to have restrictions. Both of them have restrictions for these two questions, okay? Remember to raise your hand if you finished. Okay, Vicky, what's your answer for C?
I got 6x plus 2 over 3x.
Okay, restrictions?
X cannot be 0.
Okay. Thank you. Stunk, how about your C?
I got 6x plus 3 over 3x.
And restrictions?
And x cannot be negative 1 over 3.
Okay.
Oh, wait. And 0.
And 0.
Both, I guess?
Okay, I guess so. All right. Tiana, do you have answer for C?
6x plus 3 over 3x, and restriction cannot be 0 or x cannot be 0.
Hold on. 6x plus 3 over 3x. X cannot be 0 and
Oh, I only got 0.
just 0. Okay.
Yeah.
Okay, thank you. All right, so let's go over a couple steps, right? So we start with F. We want to put F inside the K, right? So be careful here. So K of 3x plus 1, right? And our K is 2x, right? Remember, you treat this like a box, right? 2 box plus 1 over box minus 1. So the box we have is 3x plus 1. So Catherine, how do we write out the next step?
Do 2 bracket 3x plus 1 plus 1
Okay,
over
yeah,
3x plus 1 minus 1.
yeah, good. Okay, so that will be the setup. Now all we need to do is simplify it, right? So let's simplify this part. Trudy, what do you have for the top?
I have for this one 6x plus 2 plus 3
Okay, plus 3, yeah, over.
over top 3x, yeah,
3x, anything else?
they simplify
Yeah, they simplify, so it's gone.
into, yeah,
Yeah, very good. Okay, so this should be the answer, right, over here. Now let's check the restrictions. William, where did you get the -1/3?
I got it from the second line where there's like 3x plus 1. So
Mhm.
I put that in as well. I don't think I need it though, so
Yeah, so
it's
you
just 0.
you look at the very final expression, okay? So you would have x cannot be 0, okay? And then
Okay.
yeah, and
Hey,
yeah,
Then can you simplify that?
yeah, we can simplify it, okay? What else can we do to simplify more? Is it Cindy?
Divided by
I
3.
took out like 3 from the top and bottom.
Yeah, we can cancel out the 3, right? If possible. So all 3 terms, the 6, the 3, and the 3 at the bottom, they are all divisible by 3. So we could divide everything by 3 into 2x plus 1 over x. So this will be the best answer, right? So far it matches, right? You get that, but make sure you double check, okay? And then simplify as far as you can, okay? So these two are your answer. Okay, very good. Good try, okay? So trying it out, then you will know which part you need to improve, right? Okay, last part. Samantha, Catherine, and Tiana, have you finished D yet?
D.
If you finished, please raise your hand. Okay. So
D. It's the D of the town.
what? Okay.
D.
Yep.
Hello.
The fog.
Yes.
Okay,
I'm
Donna,
sorry, I listen to very weird songs.
what's your answer? Donna?
Okay.
Mm-hmm.
3 root 3x
3x
plus
plus
1
1
plus
plus
1.
1. Like this? Is it like this?
Yeah, I
Yeah.
think
You think? Okay. What about restrictions?
x
X
equal
equal
um no greater than
greater than equal
1/3.
1/3. Okay.
No, negative.
Negative. Okay. All right. And Eric, what about you?
I got 3 times square root x minus 3, and then plus 1.
And then plus 1. And restriction
X is greater than or equal to 3.
3. Okay. Samantha, what's your answer for D? Did you get this one? What's your answer for D?
3 times x. 3 times square root of x minus 3 plus 1. So
Like this?
Hmm.
And restrictions? What's your restriction? Samantha,
the same.
the same. So x greater or equal to 3. Yeah?
Mhm.
Okay. Okay. So let's check this one, right? So f of g, right? So this symbol, make sure you can rewrite it, right? It means the f is outside, g is on the inside. So g of x we have is a square root, right? So it will be f of root x minus 3. Okay, Donna, do you agree so far?
Yeah.
Yeah, okay. So our input should be the square root of x minus 3. So you put this inside the x. Okay, so it will be 3 and then box, which is the root, and then plus 1. Okay, so it should be either the first one or the last one. So make sure you won't have the 3x anymore on the inside. Okay, the inside it just stays as x minus 3. And then finally, if I want to find restriction, you look at the very inside. X minus 3 must keep it greater or equal to 0. So isolate x greater or equal to 0, right? So these are your final answer. Are we good? Anyone has question about this?
0.
Oh, yeah, I'm wrong, right? Nobody says anything except you. Oh, I did that on purpose, maybe.
Yeah, you did.
Yeah. Okay, x greater or equal to 3. Okay, so that should be the restriction. Are we good here? So what did we cover today? Okay, let's recap quickly. So at the very beginning, right, we said that we could do the opposite, right, of the operation, right, split up. After that, it's called a composite function. So this is like making product in factories, right? You put one thing into one factory, and then another thing, you get a product and then put it into the second one, get the final result. And then we went over how to get the function for the composite, okay? The h of x is called a composite function. And then that's all, okay? And of course, this one we can also go the backwards, okay? We'll do the going backwards next week. So any questions about today's lesson? Okay, if not, let's go over, take a look at the homework, okay? What will be in the homework? Let's see. So there are a couple questions I want to talk about it before I tell you, okay, to do like question 10. So please, everybody turn to question 10 here. Okay, question, yeah. Okay, so here it tells you that F is a bracket, right? 4, 5, -2, -1, 3, 4, and -1, 0. Okay, G is that. Draw an arrow diagram to find the following if it exists. Okay, so I can explain a little bit on question A first. When you see 4, 5, which one is the X? Which one is the Y? Tiana.
4 is x and 5 is y.
Yeah, okay, so that's the X, that's the Y. So that means X is the input, 5 is the output. So if I try to make a diagram, right? So I'll draw the diagram here. This is called the arrow diagram, what you will show. So F of G. So I will start with F or G. Eric, which function should be inside?
G.
G should be inside. So when you draw the arrow diagram, you'll put G first, right? It goes into G first. And then the result will go into F, okay? So let's say I want to see if it works, right? Because I start with G, then I have to look at the G function here. So for example, I want to check -2 and -1. Which one is the input, Stunks? For this one, which one is the input?
The input in the
Yeah.
first circle.
In this one, in this.
I
Which
don't
one's
know.
the X? Which one's the Y?
Oh, the -2 is the X, -1 is the Y.
Yeah. So you'll put -2 as the input. Okay. So -2 goes in, and then -1 will come out. That's how you make the arrow diagram so far, right? And then the -1 will continue to be the input. So you look at the pairs in F. Is there any pair has -1 as the input?
Second one.
Second one?
Or the, oh wait, no, the last one.
Last one, right? Input has to be X, right? So you have to choose the pair that has -1 as the input, as the X. So -1 will go in. What comes out?
0.
0. Okay, so this completes the process, right? Completes the composite function. So you'll continue to check every single one. So you check -4, right? Do the arrow diagram. You can put it in the same picture, right? You can do -4. And then what comes out, Eric? If I put -4 into the G, what comes out?
5. Or no. -2.
-2, right? Because that's X and Y. And then you go to F, because the next step is to look at F. So is there any pair has -2 as input? Samantha? Samantha? Any pair inside the F has -2 as the X? Which pair has -2 as X?
-2, -1.
Yeah, very good. Okay, so you put -2 into F, you will get -1 come out. So you keep on checking, right? So this one also works, right? So far, this pair works, this pair works. You keep on checking, okay? If every single one works, then you draw out all the pairs, right? Then that's your arrow diagram. If any one of them got cut off, then you can say it doesn't exist, right? So in your diagram, each of the 4 questions, you will have diagram like this, 3 circles, right? 3 circles, and then you try to complete the process for each point. Okay, I think that is the only one that's more confusing. Okay, otherwise everything else is similar to the thing we did before. Okay, so I'm going to post the homework on Google Classroom later. Okay, tell you which question to do. Okay, and if you have any question about today's lesson, you can stay after. Otherwise, I'll see you next week. Okay? Are we good?
Yes.
Yeah. Okay. I'll see you next week. Have a good weekend, everyone.
Bye, Jason.
Bye, Jay.
Bye.
Bye bye.